Hello, good morning. Today we will be revisiting data types. This includes a demonstration of what data types is, the classification of data types, and how we are going to implement it in real-world scenarios. So today I will be showing you what data types you were going to commonly deal with, which includes uh, the most common ones, including the primitive and composite. So this is still included in our Module 2, Lesson 1. S- Um, so now I'm going to present you what data types are. As you might have known, data types are what allows us to store data into a program that we have created. So data types can be classified into two, which are the primitive and the composite. Primitive data types are what we commonly use when we are going to store basic data. Meanwhile, composite data types are ones that make use of those primitive data types to create more elaborate uses on those data types and not only store one basic unit of information. So, for primitive data types, I've already discussed this, I think, but we will be elaborating more on how uh, these kinds of data are being stored in a program. So let's start with byte. So byte only stores whole numbers from negative 128 to 127. S- So you might ask yourself, how did it come up with these numbers? So let's show our whiteboard for a bit. So I think Sir Earl might have oriented you already on the conversions of data or um, for example, what byte is, what bit is. So Boolean stores either true or false, meaning it can only store a single unit of information. We call those unit of information bit. As you might have already, as we have already discussed in our previous lesson, computer only acknowledges a single language, and that language is either on or off. We call those binary language. So it can be represented by a 1 or a 0. It's either on or it's either off. So how do we come up with these numbers according to binary? So let's start with Boolean, which is the smallest unit of information among the list of data types. So again, if we store Boolean in our program, it only uses up a single unit. Let's say we say true. It stores only 1 or 0, depending if it is true or false. Now, for byte, which stores uh, 1 byte of information, 1 byte meaning 8 bits of information. So there should be 8 rows of numbers. So, sir, where does this negative 128 to 127 come into play? So, I think Sir Earl already has discussed this, but if we go by um, the units of the binary, we start with 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, so on and so forth. So those represent the 8 bits of data. So 2 to the power 0, any number with to the raised to the power of 0 is equals to 1. 1, 2, 4, 8, 16, 32, 64, and lastly 128. So you now see the pattern where these types of numbers come from, right? Now, you can easily imagine how these numbers are being converted into, or how these binary bits or bytes are being converted into uh, the whole numbers we are accustomed to. For example, short. Short is 2 bytes, meaning it has 8 more binary bits. So, you might question yourself, Sir, um, if I am a programmer, if how do banks store their uh, information regarding money? Do they use float, which stores fractional numbers? Do you store it in double or perhaps in integer form? Anybody has any idea? What do you think? How money is being stored from banks? Any correct answer will be given bonus points in the PT. So if you have any guesses, any kind of guesses, you're free to answer now. No, no particular guesses in the from the students. So I guess none. So for banks, they store their numbers using long. Sir, why do we store our information regarding money in long? It doesn't have any decimal points. As you might have known, we have centavos. So, programmers come up with a trick on how to store this information, on how we store financial information through a database in a bank. So, why do we use a 64-bit or 8 bytes long as a data type for our banks? So, first, they consider the smallest unit, which is, for example, 1. It is being converted into 0.0001. So that's how banks store it. Meaning, if you have in your database, if it has 10, then it will be stored as this. So let's say, for example, you have $1 of money. It is being converted via formula into something like this, if I'm correct. So, as you might see, there is a theoretical limit um, on how much numbers we can store in uh, in a database. There is no infinite. For example, 9999. That is not the case for financial information. Now, um, let's go to um, the other classification beyond primitive data types. We can consider byte, short, int, and long as integer data types. We call those integer. We call this for integer data types as they only deal with whole numbers. Okay? We consider these integer data types as they only deal with whole numbers. We consider float and double as, what do you think is we consider float and double is? No answers? We consider float and double as floating point data types. Floating point meaning fractional numbers. Any numbers that is beyond the decimal point, we consider those fractional numbers or floating point numbers. Then we have Boolean data type, which deals with either true or false, 1 or 0. And lastly, we have char or character data type. Character data type stores its information um, as a hexadecimal type. We will be acknowledging this in our future lessons now, but simply it can only store a single character in its data type. Um, I think you might notice, sir, we are dealing with string already. I don't think we are seeing string here. So now, moving on to our next one, the composite data types. Again, composite data types are data types that are making use of other primitive data types in creating and various data. So now with string, string is a special case because it is commonly used. It is widely used in most programs. It is unique in a way that some others consider it somewhat like a primitive data type, but it isn't. So, string is a character array. So, for example, if we say hello world, we say hello world, it actually stores it via each characters. We can consider it as character array. Now, what is an array? Array is making use of the primitive data types to store multiple instances of a single data. For example, we are dealing with an Boolean. Boolean can only store again 1 or 0, right? But what if we create a Boolean array? Meaning, it can store multiple instances of ones and zeros depending on how much the array size you have created is. Classes uh, are what we are dealing with when we are creating the program. So classes is given and interfaces allows us to interact with those said data. We will be encountering classes more later in our second one. Then uh, I think we are going to go with our practical activity now. So I would like you to open I would like you to open Android Studio. Then we will be creating a new project. This one will be just a sampler. So file, new, new project, then empty activity. We will name this your last name underscore data types. So for now, for the data types, we will be experimenting with uh, primitive data types. So we are going to display our numbers in our screen. As you might have noticed, there is already a hello world. we will be making use of that hello world text as a way to display our text. So I would like you to add an ID here in the attributes section. It can be seen here. Go to the attributes section, then name it display text. Name it this display text. Now, going to the code, we are going to communicate with the said text view. So we are going to call the text view class, then display. Let's name it display. Then uh, display is equals to find view by ID. Find view by ID. Let me okay. Find view by ID, then R ID, then the name of the text view that we created earlier. So now we are able to communicate with uh, the display text here. So whatever we type here, if we set this text and transfer it to display, it should display. So now let's test this up. We will start with the easiest way to display um, data type, which is string. So now we are going to create string. So string, let's say display, text display is equals to, again, if we are going to deal with uh, the string, it should be in block quotes. If you notice there is a green underline, it's just correcting us for spelling mistakes. So you can ignore any green underlines in your text. It's just notice that, hey, this might be a wrong spelling. So you can easily ignore it. So let's try displaying our name. So string, text display, then uh, so let's try running our program. So while it is running, okay. So let's see where we failed. Oh, I see. So we haven't set where we are going to display the text. So now we are going to display and transfer the text. So let's call display, then set text. Then type here text display. So display, again, text view is the display, then set text, then text display is the string in which we stored our name. So let's rerun our program again. So it should stay our name now. Okay, now we are going to deal with other data types. So for Boolean, we are only able to store, for example, am I married data type. Again, we should start with our lowercase when we are going to name our um, data types, or rather our variables. So let's type false. So again, it won't show up because we didn't display it. So because display set text only deals with string, we need to learn how to display other data types as string. This is important, especially when we're going to deal with um, phone displays, because most of the time um, numbers and text are going to be displayed in string. So for example, we have a number here, double my money. Let's say my money. Then how much money do you have? You can type as much as you want, but again, this is in double. So now I'm going to display this in the display text. So let's remove this one. If we try to paste my money here, it should throw an error because the display only deals with integer or strings. So now we're going to learn how to typecast. Typecast means converting a data type into another one. For this example, we are going to convert double into string. So for example, here, we're going to convert my money into string so that it will display in our text box. So let's type double in big letters. So we are going to summon uh, the double class instead of the double data type. So there is a difference between the small letter, which means this is in a variable. So you will notice we created a double here, which is in small letters then, but here we created double in big letters. So this way you could be able to differentiate if it is small letters, that it means we are pertaining to the data type. If we're creating double in big letters, it means you are storing it in its class. So double dot, convert it to parse double. If we type double dot parse double, it converts string to double. For example, we have a string here. String, but the value is number. Let's say string but number. But number. Let's say the number is, so even though we type this as number, we can consider it string because we instantiated it, or we declared it as string. Now, in order to convert this into a double, let's say we will insert the string but number to the my money, we are going to use double dot parse double equals string but number. So now, the value of string but number is converted to double. Now we are going to store uh, the converted number to the my money. My money. So now, what do you think the value of my money is? Any answers? What do you think the value of my money this time around? Answers? No. Okay. Hmm. Uh, Henry answered 9,999.99. So let's test your answer, okay? We will be testing your answer. Okay. Okay, let's test your answer. So now, we are going to convert the value again to string because we need to display our numbers. Again, the phone cannot display raw number data type. So we need to convert it to string. So to convert it to string, we need to summon the string class. String dot value of. So with this line, we are able to convert whatever the value of my money is into string. So we need to input this code here in the display text. So now we are going to test the code. So why do you think the value of my money is 213.23? Any ideas? So I don't think anybody has a correct answer for this, but let's go through the code. So we inputted money, or we declared my money as 99,999.99. Now, we converted string bat number 213.23. Again, this is string. We converted it into a double data type. So, double that parse double. So, this line converted string but number into a double data type. And we inserted the value into my money. So now the value of my money is 213.23. So let's I hope you recall this syntaxes. Again, if we are going to convert any number or any data type into a double, make sure you use double that parse double. So converts data types to double. So for int, it is integer dot parse int. Then, if we are going to convert data types into string, then it should be string dot value of. Any questions regarding our lesson for today? Question so far? None? No questions? Okay. Now, let's move on with character data types. Characters and strings in particular, because character, sir, my display text is in red. So Have you already declared yours here? Have you already inserted an ID in your XML file? That might cause errors in you if there is no ID in your text view here. This is a text view. I added a name or ID here, display text. So that might cause any errors with you. Okay. So now we will be dealing with character and string. Again, I have mentioned earlier that string is an array of characters, meaning it stores uh, everything that you have stored in the string as character by character, meaning it acknowledges every letter, every character in your string. So now we are going to manipulate a string. Let's go with, if you notice in our lesson, let me show you. There are several characters that we can use that are considered as escape characters. Now we are going to make use of these escape characters to display. So now let's uh let's just retain the string text display. So let's say we are going to use line feed. So let's type line feed here, then hello. So what do you think will the effect be? So let's test this out. So as you notice, it dropped a line. So that what line feed is. That is the purpose of uh, backslash n or line feed. We can use as many line feeds as we can. So as you can see, it uses the line feed value. Sir, I noticed that everything else is aligned with the exception of the name. So let's try removing the spaces or the white space here and re-execute the program. So now, as you can see, it is now aligned. So we will be experimenting with strings now. So let's say we have another string. String, uh, next string. Let's just name this next string and the value is um, mm, where's, okay. We um, can try to display strings in a multiple form, no? So let's say text display. Then we can add a text or string literal here. Wait, why is this outside? Is it plus then The plus here is not considered as a addition operator. Ha. We use this as a binder for displaying. So I if this might confuse you, we are not doing an addition operation in there. In here, we are using this to bind the strings together. Let's say next string. So let's display this. Let's remove other unnecessary information. And how do we display multiple data types uh, at the same time? So, so as you might have noticed, I inserted a value of a string, then I inserted a string literal, meaning we putted the code literally, the value, then another uh, variable value. Now, let's say we created an integer here. Integer your age. Int my age. My age. So I want you to put your age there. Then uh, put in a value, let's say 29. So let's remove this one because I don't think we are going to need this anymore. So let's leave your name here. Okay. Then your money. So let's say, let's add a text here. My name is space. Then text display, which is your name. Then uh and my age is. Now we are going to put my age here. So it should be uh string value of. Then my age. Then my money. Wait. And my money is again string value of, then my money. So let's test this line of code, what it should display. So let's try running our program. So it should display like this. So I will be dissecting this line of code so that it is understandable to you. So let's remove the other parts. Let's remove the my money first so that it you can understand this a bit more. Let's say let's end it here. So let's go back. So the display text should include my name is, then plus text display plus, then and my age is string value of my age. We add this again, we added this so that um the integer, which is my age, is converted to string so that it won't error. Because again, display can only display string variables. So we need everything as string. So does this qualify as string? Correct. Does text display qualify a string. Again, correct. Then, and mine may age is, does this qualify a string? Again, this is a string. Lastly, is my age a string? No, because it is int. Now, we converted uh, my age as string using string value of. That's why no errors were displayed because everything here is in string. Any questions? Because I think this might be a bit confusing for you. I want you to ask any question. No questions? Okay, no questions. So now, um, for clarity's sake, we will refactor text display into name display instead. So, right click, highlight text display and click refactor. Then, let's rename the variable into name. Again, use refactor when you're going to change a value so that the code uh, won't have any errors. Avoid editing something if you do not understand what your code is. So, for example, if we are going to replace this as full name, you will notice, sir, there is an error right away. This is refactoring is especially useful if you already have long lines of code. So you won't have to look for everything that you might have changed in your source code. So now um, we will be displaying the basic statistics um, that we have. So let's so we will be displaying everything. So let's remove this. So now we're going to display the name as, let's refactor this again, as, let's refactor name as first name. We are going to add this line by line. So let's name, again, we are going to refactor the name as first name instead. Rename first, again, let me refactor in peace, refactor, rename. Okay, let me rename this instead. First name. So for first name, let's leave uh your first name, then store your middle initial as char or character, um middle initial. If you don't have any middle initial, just leave this as blank like this. It considers white space as a character, okay? So I want you to leave a white space character there. Not entirely blank, but a white space character if you don't have a middle initial. So again, it stores only a single character. So it doesn't count the period. So I want you to store the single letter only. Then another string, last name. Then your age. Then um let's say um float. Let's add some things to spice this up. So float my dream TVL grade. Let's put this 95 dot point zero, something like that. Can include F ha, if it throws an error, if you type it like this, just include F. Now, we are going to display this in our uh, program that we just created. So my name is first name, then space, then string value of, then your middle initial, then um, let's break this up line by line so that it won't be confusing. Okay. Then middle initial, then another last name, then uh, let's display the age, and my age is, please include the space, then my age, then another space here, then maybe include a period. Then okay, I want my grade in TVL3 to be, then uh, string value of, then my dream TVL grade. So I guess uh, this is just our code for now. It's a bit ugly. Maybe we can um, add things like okay, let's add a few more. So let's add a line breaker here, or rather here. Let's add a line breaker, then another line breaker. So let's test the code again. Mhm. Okay, the display of your program should be like this. My name is, and my age is, I want my grade in TVL3 to be like this. So again, we use characters, strings, int, and float. We will ignore the double my money for now, but include it as a variable there. So any questions before we end our lesson for today? Questions. I know our topic today is a bit confusing, but we made use of most of the data types that we are going to encounter. Classes and interfaces will be discussed in detail in Module 3. Again, this is the output for today. Uh, it made use of most of the data types. Questions? None? I guess this concludes our lesson for today. Thank you for your participation, guys. See you tomorrow for our next lesson. We will be discussing tomorrow about um, the operators. We will be using the operators. We will be going back to the calculator and we will try to learn how to use those operators in our daily programming lessons. Thank you and see you tomorrow.